Okay, we're back on. We've been saying that in a triangle with a right angle, and how to say the diagonal side, and that's important because when we actually when you there will be some problems. They may verbally tell you so the diagonal side, but they're not going to say the diagonal side. They're going to use hypotenuse. Okay, you sort of you may not need to use this word, but when other people use it, you need to know what it is, because you can just say A, B, C, D's and stuff. You can call this, for instance, A. Normally we'll do this B, C, right? Then you call it A, B, whatever. It basically tells the story, but other people say hypotenuse. You need to know what it is, okay? And last time we did geometry. Oh, by the way, people may ask, like, you mark this thing physics. Why did you keep doing math? And these are in preparation for physics. I'm trained physicist, so I think with prejudice and bias and whatever. Mathematics serves, of course, it serves more purpose than physics, but primarily it serves the purpose of physics. At least historically, it is. Anyway, geometry, the very important thing is to prove things. Here's the problem. You basically use the skills that we've been talking about. There are two circles intersect this way, right? You draw a line. This is intersects at two circles intersects at A and B, right? You draw a line through AB. Hypothesis number one probably is Euclidean. That from 2 points you can draw a line, and this line can extend. Okay, this is hypothesis. Okay, just like the inner angles of the parallel lines are equal, or is it? I don't know how to call it. That probably in other words we need to look it up. That when there are two parallel lines, right? How do you call these two angles? There's a special way of calling it. Inside angle, inner angle. No, it's some kind of inside word, but I'm not sure which word they use. But anyway, when you draw a straight line from these 2 points, any points on this line, if you draw a tangent line on these two circles, PQ equals to PR. Okay, mind you, these two are different diameters. Doesn't matter. Yeah, you prove it. Okay, that's problem number one. Problem number two. These are very easy problems. Problem number two. Okay. Equilateral triangle. This is the same length, 60 degrees inner angle, and you have these three segments, B, E, C, D, and AF, same length. Proof this small one is an equilateral triangle. Same side length, inner angle 60 degrees. Yeah? Make sense? Can you prove it?
No.
Can you prove? Yeah. Can you prove? Can you prove this one right now? Can you see right through it? These two, anyway, I just screwed around the internet and looking for some problems yesterday, and these two, I see the solution immediately. I just take a look at it, I see it. We're here talking about the theories of tennis, right? Or theories of whatever. Or say saxophone, right? but a key chart with the instruction find the sweet spot on embouchure, that doesn't constitute a good saxophone player, right? This is playing. Okay? Yeah. This one you should be able to see it right away, because this is directly what we said in the examples. Okay? This is easiest, and this one is a little harder, but not by that much. Okay. Now I'll give you a couple of ones. I'll give you a couple that I did not see. I actually took time to try to prove it. Okay. Here's one. This one I actually did some processing. The problem is more convoluted when they put it. They tried to put some more smokes out, but I took the smoke out essentially. Here, look, there are. This is this right angle. Okay, you get it? This is the point on this, on this right angle line. Okay, then this equals to this. AC equals to AD. In other words, this is whatever this angle equal to this angle, whatever. This side equals to this side. Okay. How do you call the triangle that has two sides that's equal, not all three?
Isosceles.
Yeah. Good. You know how do you spell that word?
I don't know.
Okay. Anyway, you guys need to know the word. Okay, because when they give a problem, they may just say it. Okay. Okay. Now, this is the middle point. Okay, so you draw the middle point here. G is this middle point. Okay. Now, FG is perpendicular to BE. You prove it. Okay?
Oh.
And for this one, I just help you out. You know when you prove things, you just draw like extra lines like crazy, right? See if anything can help you. This one, you need to draw this line and this line to help you out. Because without these two lines, right? The middle of this point, draw a line, and the middle of this point. By the way, F is middle of this point, middle of this line, AC. All of these middle points, you draw it doesn't mean anything, right? It's not connected to anything. You're looking for connections of all of these concepts, and these two lines is sufficient for you to find the answer. Okay. All right. Now, let's do another one. Okay. Let's just say you draw two lines. Okay. Make it equal. Let's go down equal. Okay. This is A, this is B, this is C. Okay. AB equal to AC. Yeah? You got that much?
Yeah.
Okay. Let's see. Then you draw a line connecting these two. Let's here, let's call it D. And you draw an angle here, which is A. What was A? This line? This is by A. Okay. This is called E. Okay. Angle BAC. Angle BAC. This equals to CED. If I write this, are there any problems?
No.
Okay. Angles. I don't know why they do this. This is very, very confused. To me, this is clear enough and correct. But for you, no, because I read your textbook. They separate the measurement of an angle and the angle itself. In other words, angles cannot be congruent, cannot equal. The measurement of angle can equal. In other words, either you write this, an angle is congruent to the angle, or you say measurement of BAC is equal to the measurement of CED, right?
Yeah.
Say that measure equals to 90 degrees or something, right? This does not equal to 90 degrees. By the way, if you have no clue about this, oh, I haven't done the thing yet, right? Okay, now let me see what we're gonna do about this. Okay, now angle BAE, this angle equals to AEC. Wait a minute, is that true? BEA. Oh yeah, okay. Sorry, huh? The angle BEA, this angle equals to AEC, this angle. Okay, then need to prove it. Okay. From this proof, angle BEA is congruent to angle AEC. Okay. Say it again, okay? This equals to this, right?
Yeah.
And then you draw this line is almost random, and then you draw this line, so this angle is equals to this angle. Right? If you do those, this is fixed, right? This equals to this. Now I put all the markers on it. By the way, if you want to say a segment marks a segment of the line equal to another segment,
Yeah, I know.
do these dots in the middle of that segment. Yeah. So you read this, you get your habit. This is talking about this segment, not this segment. You know. Yeah. So all of these conditions are on this now. Let's say you don't know. You have no clue, right? Make this angle 90 degrees and try it. And try how this work out. Make it 60 degrees. If after 90 degrees you still cannot prove it, right? This is not a condition, by the way. Okay? Make it 60 degrees and try it again. Okay? In math, many times, but if you, it took me, I didn't try it, okay? When I tried to prove it, I didn't try it. I just screw around a little bit, and then I see how it's proven, okay? Do we have 3 problems? We have 4 problems already, right?
Yeah.
Okay. The first 2 should be just, oh yeah, this one, yeah, right. The first 2 you should just get it right away. There shouldn't be. If you have a problem with the first 2, just go look at the notes of my lectures, right? This one and this one. Not that straightforward. You need some thinking, but all the knowledge is needed in there are actually these kind of geometry proof problems. All the knowledge is contained in what I said. Now, I just want to say one more thing about geometry before we move on. we said you need to really look out for you need to really look out for parallel lines, right? In our proof, in my proof of things, even there's no parallel line. You remember a triangle? We make parallel line outside just to create some parallel lines, so we can do some business. Yeah. Once you have parallel lines, once you have parallel lines, right? Anything that goes through it, any lines that go through it, like these lines, they create similar triangles. And these similar triangles, all the angles are the same or whatever, right? I want to say that in a circle, you have more or less the same thing. You have a line like this that creates similar triangles, right? Same like that, right? When you have a line that cross that creates similar triangles. You know where the triangles are, right?
Yeah.
What I'm talking about, right? Yeah, this. This we can for instance we can link these. Okay, we can link the other things too. We can link these two also forms. It depends on the situation. So any 4 points, I want to say something. Okay, like this, for instance, right? If you have a problem, this angle plus this angle equals to 180 degrees. These 4 dots are on the circle. When you have 4 dots, watch out those 4 dots. If 4 points are on the circle, you need to draw the circle. Because once you have 4 points, 4 points are on the circle. You always watch out which points are on the same circle. Circle is a beautiful thing. Once you're on the circle, all the angles that are riding on the same arc, they become equal. All kind of properties, circle properties you can use. Get what I'm saying? No? Let's just say they tell you this, right? They give you give you this. They tell you this, yeah, and this plus this is 180 degrees, right? Then they want you to prove, for instance, this angle equals to this angle. Okay? Okay? How do you prove it? All you need to prove is these 4 points are on the circle. Then all the mounts. So this angle and this angle is riding on the same arc. Yeah? First, you prove these 4 points are on the circle. When this is opposing angles 180 degrees, they are on the circle. Did you see it? You don't?
No, but I just didn't understand what these angle markings were.
Oh, yeah. Oh, okay. Yeah. Okay. Never mind. Let me do it again. Right. Like that. Right? Like this. Okay? We say this angle, okay, plus this angle equals 180 degrees. Now I want to prove this angle plus this angle. No. This angle equals to this angle. Okay. Actually, when you prove it, you say draw a circle. Any 3 points, you can draw a circle. Draw a circle on this. This point is on the circle because this points to a arc on this side, right? Then the arc on the other side is 180 degrees minus that angle. Therefore, all the points on the circle, right, satisfy that. and only those only those points on the circle satisfy that condition. Get it? Because this is whatever. This is alpha, right? Right. Every point on this circle qualify for this pi minus alpha. Okay. And if you draw a point outside, right, the angle will be smaller. Inside will be bigger, obviously, right? When you have an angle on the side, right?
Yeah.
If you draw an angle that's outside, more outside, this angle will be smaller than this one. If you draw inside, this angle will be bigger than this angle, right? So all the angle that qualify for this is on this arc, on the same circle. We want to really elaborate on proving this.
Okay.
Then you prove this point is on the circle that you drew from these three lines. You following me?
Yeah.
Yeah. Okay. Now, once this is on the circle, any of the angles that are riding on the same arc is equal. This angle equal to this angle equal to this angle, this small angle equal to this small angle, whatever. What I'm saying is, once you get this angle and this angle plus is equal to pi, right, 180 degrees, you get all of these equal angles coming your way. But if you don't draw the circle, right, you don't see it. For instance, this angle, this small angle equal to this small angle. All of these angles are the same, right? All of these. What's the next sentence I'm going to say?
Are congruent.
No. All of these triangles are similar. The sides are proportional, right? All of these triangles, this triangle, this triangle, this triangle, this triangle, all of them, right? They're all similar.
Wait, but that's just because you just drew two lines in the middle of it.
Huh. Right. Yeah. In a real situation, these lines, always draw these cross lines. They help you out. And one of the problems, this problem, right? When you have a situation, these two lines I draw, okay? B, F, and FE, I drew it. It's not in the problem. When you look at the problem, they don't have those lines. Also, they don't have this line either. Oh, this is basically, by the way, you can treat that as a hint. Nobody said when you draw this line equal to this, right? You have to be straight up, right? But say I have no clue about it. I drew this by mistake actually, but anyway, this is a good example. If I say I have no clue how to prove it, I don't get it. Just fix a condition, add a condition to it. Let's say this point is straight up, right? Then take a look how that works. And then you drop it down to a random point. Now prove it again. But when you draw this line, right, this point, right, this is this middle point and this middle point. The middle point got no connection to anything. You start to draw lines from this point to all of these other points. So this will give you some angles you can work with. And look for circles. Once you realize four points are on a circle, you look for the circles. Can you see what 4 points are on the circle right here?
Yeah. These four.
Right. What else can you see about that circle?
What do you mean?
A circle has what? What are the unique points on the circle?
The middle.
Yeah. Where is it? Where is that? Why?
Because, like, A is the biggest. It's probably gonna be the middle or something.
Which one? What are you saying?
Because A is the biggest.
What do you mean A is the biggest?
Bigger than BC.
AE is bigger than BC. Oh, well, watch. This point, and this point is on the outside of the circle, right? Because this angle plus this angle equals to 180 degrees, right? They're both straight angles, right? By the way, the problem didn't give you that's a straight angle. They just say this is the middle of the line, middle of the point. Those I give it to you, just as a system to help you out. Where is the center of the circle? Which point is the center of the circle?
Between A and E.
Really? Look, it's a circle like this, right?
Is it G?
Is it?
I don't know.
Think about it.
F?
Good guess. Why is F?
I don't know.
Look. This is the right angle, right?
Yeah.
Right angle is 90 degrees, right? What arc does it write on? It write on when you have a circle, right? The angle that write on it compared to the angle that that goes through the center, this is half of this, right? When this is 90 degrees, what's this angle?
100.
And that make it a straight line, right? It's a straight line going through the center of the circle. What's that?
Diameter.
Right. And the center of that diameter is? Because they tell you this equals to this. These are all middle points. So this one is the center of the circle.
Wait, but the B. Okay, never mind.
Say no.
B and E are also like on the side of the circle too.
B and what?
E, they're on the circle too.
You mean G could be the center too?
Yeah.
What's the angle? What's this angle? Do you know?
No.
This is a smaller angle. This in our way to draw lean like this, right? You put the D over there. That'll reverse, right?
Yeah.
On this side, the way we draw it, this angle is bigger than this angle. In other words, it'll be like this. The angle looking at this is small. The angle looking at that is big. They're not equal. But once these two angles are equal, this thing in the middle, equal being 90 degrees.
Okay.
You get what I'm saying? You draw it straight up, that's 90 degrees, right? Now we lean it over, so this angle
Yeah, I know
is
that.
greater. So this line is leaning on this side of the center of the circle, which is the way it is. Of course, this is center, right? This lean this way.
Okay.
But this is 90, this is 90. When they're 290 degrees, right, facing each other, that line is right in the middle.
Okay.
And that makes this line a diameter. Okay?
Okay.
You have a problem to see this line is vertical now? Well, you figure that out, okay? It becomes very, very simple. Okay, actually, we're running this thing so long. This is basically a length of normal video we do. So we'll just stop here. See you next time.